In this virtual training, we're going to show you how to connect through an optional proxy server and send OPC data via MQTT to Azure. Now, this training does assume that you have seen one of our prior trainings that shows how to connect the data hub to an OPC DA or UA server. In this training, the first thing that will happen is we'll show you how to connect to a proxy through a proxy server, which some IT departments require to get through a DMZ, and then how to use MQTT to move that data on up to the Azure IoT Hub for your digital twin or other related applications.
So this part's done, right? We just need to add this write-only connection to the DMZ data proxy. So we're actually going to set that up in the data hub on the OT side where it pushes to the data hub on the DMZ side. Let's go ahead and do that. So if we're going to go to the tunnel section, we're going to add a connection to another data hub. We're going to put in the IP address that we're going to be pushing to. I'm going to put in my username and password. And then it's critical that we make this a write-only connection. So what we're going to do is we're going to say that this will only write data to this data hub on this IP, which means that all this data is read-only, which is great. We don't want, this is our operations network. We don't want to write back data. We're really just trying to publish data to the cloud. We don't want any chance that the data's changed. So we're going to click yes. And then we need to set up our local and remote data domain. So anytime you're setting up a tunnel, the local domain is the domain on this data hub, and the remote is the domain on the other data hub. Now, because we're pushing, the local domain is our source data. So remember, our source is called top server. And because we're going to use this data in Azure, I'm going to call my remote data domain Azure.
Hey, Wen?
Yes.
Can you clarify what the remote username and password means?
Sure. So I've set up security on my remote data hub to ensure that not anyone who knows this IP and this port number and this data domain can just push data to me, right? So by creating a username and password, we've secured our data hub that's living on the internet so that not anyone could maybe connect to it or push data to it. You know, if I didn't have this, then as long as someone knew this IP address and this port number, they could push data to my data hub from another data hub. So this allows us to safeguard that. Let's go ahead and we're not going to mess with any of these other settings. Let's see, I do want to make sure that if the connection's lost, data is marked as not connected. We do want that. Okay, perfect. So click OK. Click Apply. Of course, SSL is not working. That's okay. We'll try plain text, and that did work fine. Okay, so what I'll do, I'm going to show you the data hub living in the DMZ and all that's required on it. Okay, so this is my DMZ data hub in this virtual or remote desktop session here, and notice I'm accepting plain text on this port, and I'm accepting secure on this other port here and using this data hub certificate. So basically this says, hey, listen for connections from another data hub. And then as John mentioned on the security side, I did set up an SWTB admin user that has full control. And that way that user can read, write, and subscribe to all the tags. So to confirm that we have the data, I mean, obviously we can see that we have a connection here, but if we go to view data, we have an Azure domain, and under the Azure domain, we do have some simulated data that I'm pushing from my other data hub. So again, anytime the tags change on this data hub on the OT side, it will then push that change to the data hub on the DMZ side. So that's really step two. Most of the configuration was on the data hub that's pushing. on the data hub that's listening, you really just have to make sure you're listening and set up the optional security. So now let's move on to part 3. So we've gotten this first 3 pieces done, right? We've connected to Data Hub, we've tunneled the data to the data proxy. Now we need to set up the connection to Azure. So there's a couple of things to know about that. The first thing is Azure provides a tool called the OPC IoT Explorer. Let me pull up a page. This will be linked in, so one of the things to know about this, I know some people are following along. This part, it might be a little harder to follow along with. So what I would say is we do have a PDF document that walks through all of these steps that we're going to provide with the link to the recording today. So I would walk through that. That covers all these steps, including downloading the IoT Explorer and generating the password the Data Hub needs. So we will provide that so you don't have to follow too closely along because there are some complex steps here. First, we have the Azure IoT Explorer. This MSI here is what you would download and install. That gives you access to this tool here, which I've already downloaded, and the Azure IoT Explorer will allow you to create the password Data Hub needs and also monitor any traffic between your Azure IoT Hub. One thing it does need is a connection string. So the first thing we need to talk about is where do you get that connection string from? Okay, so let's minimize this Azure one here, and let's pull up the Azure portal. So in this case, I've logged into my Azure portal, and I have an IoT Hub here. My Azure IoT Hub is called SWTB OPC UA Hub. And remember, what we're trying to get here is this IoT Hub connection string for the IoT Explorer. So what we need to do to get that is go to the shared access policies. Now, a shared access policy, think about it like a permissions policy, right? I mean, in this case, I have a Data Hub IoT or an IoT Hub owner, and what it can do is do writes and basically has what I would call full permission. So I'm going to go to that policy, and then the connection string it's looking for is this primary connection string. So you can copy that to your clipboard, and when you paste that into this place here and click connect, you can see we connected to my SWTB OPC UA Hub, right? And it lists my devices here. Okay, so the only thing you really need to log into Azure for as far as when configuring the Data Hub is to get that connection string, which will allow you to open the Azure IoT Explorer. Okay, we're getting there, guys. So now we've opened up our test device, and what we're gonna generate an SAS token here. You want to select a primary key, and then you can give it an expiration in minutes. I'm going to make mine expire in 30 minutes. However, it does support a very large number. I believe that's something like 17.14 billion years. I think at that point you can safely call that someone else's problem. So, you know, for my demo though, I'm going to say 30 minutes. We're going to generate the token and copy that to the clipboard. And I will show you what part of that we need for the Data Hub password. So just I'm opening up something to paste this in, and then what we'll do is we'll get back to our Data Hub, not this one, we want the DMZ version one. So let me get that up here. And there we go. Let's make this big. Perfect. Okay. So I'm going to show you what my connection string looks like. because again, it could only last for 30 minutes. If this was an unlimited connection string, I wouldn't show this to you guys, right? So what we're going to need, so here's the whole connection string. Let's start configuring the data hub, and I will show you what part of this we're going to need in the data hub password field. So we'll move this off to the side. We know we're getting data, so that's great. That's the data we're going to publish to Azure. So at this point, we need to create an MQTT client connection to Azure. So we go to the MQTT client connection in Data Hub, we click Add, and we have templates for the most popular IoT hubs out there, which make it pretty easy to put in the information we need. So we really need the hub name. We need the device name, which was test device 2. If you know those two things, and then we have this shared access signature that we're going to need, that's really it. Because if we click configure, notice it populated the host IP address, and it tells us the Azure IoT device password must be an SAS key starting with shared access signature. All right, so what the heck does that mean? Well, what that means is we can ditch everything before this shared access signature SR and everything else. What we need for our password is right here. So if we copy this, we go back to our data hub, go to the authentication. Notice that configure button has also set up the client ID, the username, and all we need to do is paste in the password. So now we've set up the connection to Azure. Now we just need to define what tags we're going to push to it. So I'm going to go to my functions here, and I'll publish a couple tags. And let's click OK. Let's click Apply. And that is working. That's great. And if we go to, I told you we could use the Azure IoT Explorer to monitor the connection. You go to the telemetry section and hit Start. And that's under the specific device that you're using. And this will show us all the messages being passed. You can see here we're getting quite a bit of messages because we're moving data rather quickly. Okay, so I do want to turn this off real quick, and then I want to edit it and show you some other ways you can send the data. Currently, let's pull up the IoT Hub again. You can see the format. We have a value, quality, timestamp, and sender. Okay, that's great and all, but what about the tag name? How does my Azure know about that? Well, that's something we can configure in Data Hub. I purposely left it off. So if we go to our message content tab, we have our message format here, and we can edit the format. So if we edit the format, we can, let's put a point at the beginning. So I'm going to put in point name. And you just type in one of these placeholders here. And these placeholders represent the tag name, value, quality, quality name, timestamps, and sender IDs, another thing. Also the MQTT topic. Now currently we're sending 1 point per message. You could, if you did a per point separator, you could send multiple points within a single message. Just have to specify a message start and a message end character as well. And then we would, bulk send these into one packet as opposed to 1 packet per tag. So it depends on how you want to send that data. We're pretty flexible in the Data Hub, and I don't want to cover all the use cases because really how you use this data and how you format the data you send to Azure depends on the data you need up there. So it's all very application specific. So let's just click OK. Let's enable our connection. Click Apply. And oh, yeah, you can see I goofed right up there. That's not supposed to be there. All right, try again. Again, if you don't do this perfect, it's easy to find out that you messed up, right? I should have used a curly bracket, not a regular bracket. Click OK, and apply. And there we go. We have the actual point names, ramp 1, ramp 3, so on and so forth. And we can see that we're pushing this to the Azure IoT Hub. All right, so that's the end of part 3. We're going to minimize the DMZ computer. We're kind of done with it. We can move the IoT Explorer out of the way. We need to just get back our main data hub here. Let me remind everyone what we're doing next. In this last part, we are going to cover how to have the data hub listen to MQTT client devices that are publishing data to the data hub broker, how to interpret those messages and convert them to OPC items. So let's go ahead and do that next. Okay, so first thing I need to do is spin up my devices. Okay, they should be working, but they're not going to do anything because at this time the data hub is not listening. We have not enabled data hub to MQTT broker functionality. So before we do that, I kind of want to walk through the settings and show you what we're doing here. So we can listen for plain text on a specific port, and we can listen on a different port for secure SSL connections. We have multiple ways that we can either route the data or maybe parse the data. So in this example, we are actually going to parse the data out. If you wanted the data hub to just be a straight up broker that brokered the MQTT data and didn't do anything with it, well, then you could say do not process messages, just route them, and then data hub literally just acts as a broker, right? But the power in the data hub is when it acts as a broker and can interpret this data and break it down into its individual points, so then you can share that data with your HMI or SCADA system. So we are going to expect the message in the format of point name, point value, and then point quality. Okay. If we do disconnect, or if our clients disconnect from us, we will mark the data as not connected. And that's really the extent of the configuration. So before I click apply, I do want to bring up the connection viewer because we will be able to see what's happening in here. So click apply, go to my connection viewer. So you can see the MQTT broker started. And what we should see here shortly are a few clients connect in. So let's see if we can get that to happen. There we go. We have the 3 clients have connected to my data hub. I have device 1, device 2, and device 3. And you can see the number of tags we've received. And we've created a total number of 15 tags across these devices. So if we go to view data, we can actually see what this data looks like. Each device has an alarm, a flow rate, a pressure, a tank level, and a temperature. And it's changing pretty rapidly, and you can see that we have good quality on all this data. So at this point, we've now accepted the data from the MQTT client, and it can be exposed in any format the data hub supports, right? These are just data hub tags. It's another thing that I really like about the data hub is this tag here, this tank level, is really no different than this tag here in data hub. Data hub doesn't know that this tag's an OPC tag and this tag's an MQTT tag. They're all data hub tags. So at this point, we can do anything with it that the data hub supports. So let's open up my OPC Quick Client. And what we'll do is we'll make a OPC DA connection to the data hub. We're going to add a connection. We're going to connect to the Cogent Data Hub. We're going to add a group. We're going to scan at 100 milliseconds. Click OK. Add some tags. I'm going to add those. Device 2 tags. Device 3 tags. You can see we have 15 total tags. If I click OK, again, because the Data Hub supports server, OPC DA server, OPC UA server, we can serve this up to pretty much any HMI or SCADA system that supports any of the OPC protocols. So all this data could be fed right into there directly from MQTT Client enabled devices that are maybe out in the field.